Okay, so are you ready for chapter 6, producing food? So, continuing and getting towards the end of the class. So, making some progress here. All right, so as always, now these are the objectives. Again, just like the last chapter, I don't think we're going to finish with 6.1 through 6.4. So I'm just going to keep it 1 through 3, and then we'll continue next week. Okay. And don't now there's a TED Talk and of course a post, and you'll want to see that. It's interesting. So one of the things I wanted to mention, the title is "Why is Organic Food So Expensive?" And this is from Ali Pertovi. And I just wanted to make a comment, and that is, yeah, I mean, yeah, as far as the swear words, let's just say I imagine he just feels very, very passionate, but his swear words don't get too bad. So forgive me if, if it's something you're not really accustomed to. Uh, Take note of that the first post should be 200 words and the second 100 words, okay? And make sure you look at the description, and there's, of course, the rubric that will be posted as well. Sorry, yeah, and these are the competencies for this week, and these are the terms. Okay, moving on. Modern crop production practices. Okay, 6.1. So we have a picture of a nice American farm. And of course, we like to think that this is where all of our food comes from. Or we just like to think it comes from Baker's or Hy-Vee or Walmart. But things have changed, and this really reflects what my uncle's farm used to look like. No, this isn't my uncle's farm, and I did try to find something to show you what I was accustomed to. Now, I was a city kid, but my parents didn't have a lot of money, and they still wanted to get rid of me during summer vacation because we couldn't afford summer camp. So then they would send me to my aunt and my uncle, who was more than pleased to get more. Well, let's just say that being the child of a farmer is the only legal type of child slavery that is allowed. But we used to have a lot of fun on the farm, and you know what? In the summers, it was fantastic. I had 5 cousins, and we worked really hard. There, you really couldn't get TV reception. We only had 3 channels anyway back then, and that was in the city. But we played cards and we laughed until we pretty much fell out of our chairs. And I think my cousin Peter Pants once. You don't know her. You'll never be able to tell. But my uncle had a farm really similar to this. He had sheep, he had pigs, he had chickens, he had just a couple goats, cows, dairy, as well as cows that would be slaughtered. And he raised just about every kind of crop that you could imagine. And I'll be bringing back some of his agricultural procedures a little bit later on. But all right, so this is actually to reflect some of agriculture in the 20th century. So okay, this was considered modern distribution at the turn of the 20th century. So you had a truck, and produce and other types of groceries probably didn't come very far. So there wasn't a big fossil fuel type of investment to get the food from the farmer to the grocery store. And the grocery store pretty much stocked what was in season. So if they didn't have it, you didn't get it. All right. Refrigeration was rather limited. So again, you had everything was fresh. There was no preservatives. They came right off of the farm, all the nutrients, hopefully intact, and you would eat them. And there you go. Now, today, okay, this is where the chickens are found for most of us. This is where the hogs are found. This is where the cattle is found. And of course, we really don't have much in the way of a diverse crop in this country. Most of the crop, especially in Iowa and Nebraska, all you pretty much see is corn and soybeans and Corn is put as pretty much a food additive into everything, or a lot of it, and a great deal of it is used to support the operations that you see up here that we'll talk about a little bit later on, because yeah, it's a major feed crop. Okay, and distribution has changed. So, yeah, are you getting your fresh produce from the neighborhood, or I should say from the local farmer? Hopefully you are, but most people get it on, whoops, most people get their produce shipped from overseas. Um, a lot of fruits and vegetables, I know we get an awful lot from South America, actually. And okay, and things are shipped in by and semi. And have you ever been behind one of these trucks? Well, if you live in this area, you probably have. If you've ever been on I-80, you have. And of course, then there's processing plants like this one. Okay, so food looks a little different, and the distribution, well, and as far as the local grocery store, we don't have a lot of those. We have these, and these, kind of mega complexes is what we've got. And well, and again, food, this kind of food would have been unrecognizable to my grandparents in their earlier days. But this has pretty much dominated the American diet, unfortunately. So let's look at some key features of U.S. agriculture today. And I know there's a very sad looking potato that's rotting over there. There's a point. I'll get to this. In the United States, we really don't have a lot of variety of crops. Again, it's corn, it's soybean, it's cotton, and most everything is the same species. So that lack of diversity, that having the same species, is called monoculturing, or sometimes a monocrop. And there are consequences to this. And well, for example, as a biologist, we know that the most stable ecosystem is that ecosystem that has diversity. Biologists love diversity. Okay, we just do, because we know the more species there are in a nice balanced relationship, the healthier that ecosystem is. And then if something comes in to disrupt that ecosystem, I mean, it could be a change in weather, or it could be global warming, or something like that. Well, okay, you have a diverse number of species, and most of the species will rebound back and keep the ecosystem healthy. All right, this is something it doesn't have if you only do monoculturing. An excellent example of this would be, the potato famine that hit Great Britain. If you have ancestors that came from Great Britain, you are probably here because of the Great Potato Famine that hit in the 19th century, so mid-1800s. And here's what you need to know. So the potato is not native to Europe or Great Britain. No, no, no. It was brought from the Americas. And it was brought actually to Queen Elizabeth, the English queen. And she thought, these are really great. And there were a lot of varieties that were brought over, but they found that there was one potato that had the best, gave it the best production. You got the most potatoes, and you can plant them, and they give you several yields before winter hit. And so in Great Britain, they moved from diverse crops of potatoes to pretty much a monoculture. And then they had, a very wet, cold spell that lasted for a few years, actually. And because of that, there was a blight that hit, a disease that hit the potatoes. Now, if you were a poor farmer in Great Britain, then the poorest would be from Ireland. But this also it also hit Wales and Scotland and a lot of places in England. But if you were a poor farmer, you were barely making a living anyway. You had to pay your landlord, so you had to grow enough crops, and the land wasn't all that good. So you'd have to grow enough potatoes to feed you, to feed your family, and to give to the landlord to pay for your rent. And it was really hard work. Now imagine if the potato is now gone. What do you have left? Nothing. So it destroyed many people, and a lot of people starved to death. So this is the lesson of monoculture. It's not a good idea. Okay, you might have noticed also all the construction people started to plant the same pine tree around Omaha. And now those pine trees are dying. And I lost one, but I've been having to use, unfortunately, a pesticide to save the other ones. Actually, it's an interesting drug. So yeah, if you travel around, you will see monoculture everywhere, and it's mostly corn and soybeans in this area. And to keep this going, then again, you have to have a lot of chemicals. Okay, and big machinery. Okay, and in this is kind of the bread basket, one of the bread baskets of the world here in the Midwest. So it takes a lot to keep this going. Okay, machinery. And oh, by the way, so these chemicals, a lot of them have fossil fuels, pesticides and herbicides contain a lot of fossil fuels. While you're running the heavy machinery, what do you think runs those? Oh, yeah, gasoline and oil to run those big machines. And then, of course, you have to ship it somewhere by rail or, well, semis. That takes an awful lot of petroleum products. And then you package them up in a factory that, again, fossil fuels. And then the plastics, okay, fossil fuels. So, yeah, it's kind of an interesting system that we've got here. So we have a very heavy reliance on fossil fuels. Now, on top of that, because we keep increasing our demands of our soil and from our Midwest where we grow these crops. Well, there's a big demand for water. Plants need water, and everybody does. So where are you going to get those resources? Well, a lot of the water is being taken from the ground, and some of that groundwater cannot be restored, and we're losing our groundwater. Okay, and one of the practices, and I'll come back to this a little bit later on, in this area, of course, we do a lot of irrigation. So we pull up groundwater and we pump it and we spray it. And this is really, it looks like a wonderful way to keep your field nice and green and your plants very healthy. But understand when you're spraying all this water that you pumped up from the ground and you're spraying it on a hot August afternoon or, well, just on a hot summer day, you're going to lose a lot of that water in the form of evaporation, and it's not going to get back into the ground. It's going to go up and it'll come down someplace else, but you're not going to have it available for this field. Okay? All right, so speaking of those chemicals, let's talk about intensive use of fertilizers. And okay, so a lot of fertilizers contain the type of material that we used to get from animal feces. So back to my uncle's farm, if you needed fertilizer, you just cleaned out the pens. And the cows and the pigs and the chickens were more than happy to supply those. And here's the thing. So plants, they need sunlight, they need water, but they also need certain nutrients. They need nitrogen, and that is usually given to them by artificially by nitrate fertilizers. So, okay, so you have to make these particular chemicals, these fertilizers, and you spread them around not only your fields, but also yards, by the way, to fertilize your fields. Now that seems like, okay, so what's the big deal? You make plants happy. When it comes to nitrate and nitrites, they're pretty much the same. And when they get into drinking water, it's very hard to control that in your municipal water system, but it has a very direct effect on human health. And in fact, nitrites can change hemoglobin to a form that can't carry oxygen. And this causes a medical condition called, I'm going to fall over it, methemoglobinemia. Okay, almost nailed it, but not quite. Another word for that, well, the methemoglobinemia is what we commonly call, what we call the condition in an adult, but in babies, sometimes we call it the blue baby syndrome. So when a woman is pregnant and she's been exposed to too many nitrites or nitrates in the water, it can cause blue baby syndrome. Good grief. My apologies. And sometimes this has a very bad impact on the fetus, and the moms can lose the babies, or the babies can be born without getting enough oxygen. So this can cause some very serious hazards to babies. Okay, so moms really have to look out for the quality of their drinking water, especially if they live around agricultural lands. Okay. This is a little something from the Omaha World Herald, and the title of the article is Iowa Legislature Poised to Dissolve Des Moines Waterworks, Likely Ending Water Quality Suits. And this is from 2007, March 11th. And what happened was there was a utility company that was supplying drinking water to Des Moines, and they were spending just millions of dollars trying to get rid of the nitrates in the water. And so very, very hard to do this. Okay, so everybody upstream was dumping nitrates and nitrites in the water. A particular offender was a hog facility owner, and they filed a lawsuit to force these counties to clamp down on the runoff and just say, okay, you have to watch what you throw into the water, because people in Des Moines are getting this, and it's costing the Des Moines taxpayer an awful lot of money to try to get rid of this. The state legislature actually decided to address the issue by dissolving the whole utility and saying, well, yeah, so if they did that, then there'd be no more lawsuits. So just get rid of the utility that's watching out for nitrites and nitrates in the Des Moines water area. So GOP lawmakers say the change is meant to allow the cities in the area more direct control of their own water. How nice. So the cities get to decide what goes downstream. Yeah, what can go wrong with that? So yes, people in Des Moines were not happy with this. The big fight and the reason that the state legislature got involved was because, again, there was a big pig farm operation and they were mishandling hog waste. So, yeah, the utility kept saying, okay, clean up your water. And they weren't the only, now the hog confinement uh, farmer wasn't the only one that wasn't doing a good job of watching what got dumped into the water, but they were one of several communities upstream and organizations upstream. Just a little side note, federal regulations require nitrate levels below 10 milligrams per liter. And but the river that this particular utility company was cleaning up had levels that were 4 times that amount. So again, think of the babies, right? And the poor pregnant women, how scary for them. And they probably didn't even know that there was a risk. And this was also backed by Terry Branstad. He said that officials should rely on voluntary methods to reduce pollution from farms. And again, so we'll just rely on you to regulate how much waste goes into the waterways and affects people downstream. And of course, that wasn't working before, so why this would work in the future, who knows? But Yeah, so this was a big thing in the news this year. I don't know if you missed it, but there you go. So here are all the nitrate sources. Again, it could be from agricultural runoff, but also from the fertilizers you put on your yard. It can come from your pets, but also from if you have any kind of uh, animals like a hog confinement, or if you're just basically any animal could dump nitrates in the water. And once it gets down into the groundwater, of course, it will flow probably into somebody's drinking water. And this just shows an easy way to show this. So let's say you fertilized this particular field with your nitrates, and you get a little bit of rain and down it goes into the gully, and this dumps into, well, all of your your major sources of drinking water downstream. So just something to think about. Now, and if you're thinking, well, I'm not pregnant, hopefully that's not what your thoughts are. But there's other consequences, by the way, to having runoff from the fields when you have a lot of fertilizers, is that you can lose a lot of your healthy ponds and rivers, and even your streams can be quite toxic. This whole process is called eutrophication. So eutrophication is an enrichment of water by nutrients that changes the aquatic ecosystem. Remember what I said, if you're a plant, you only have a few things limiting your growth. So number one is sunshine, number two is water, and then you have these little trace elements like phosphates and nitrates. And boy, that those are usually very limited in a very balanced ecosystem. So down here, we have a cartoon of what a pond might look like. And if it's nice and balanced, you have a few nitrates and nitrites from, oh, say, wild duck feces, or wild bird feces, and from fish feces, and it's taken up in types of grasses and algae and that sort of thing. And the algae, which are also photosynthesizers, and the plants, again, they never get out of control because there's a limited amount of phosphates and nitrates. Now, because clearly there's not a limit on sunlight and water, but definitely these trace minerals are not very plentiful. Oh, unless you have runoff. So if you have runoff that runs into this ecosystem, the algae and the plants have nothing to stop them. So you get what sometimes they call, at first, an algal bloom is the correct way to describe it. So the algae just grows in a crazy manner, and so do the plants. It gets so bad that it blocks out the sunlight, so anything underneath is not going to get any light. And this overgrowth also will cause the plant life and the algae to use up what oxygen there is in the water. So again, with increased algae in plants, you're going to deplete your oxygen. So, all right, what are the fish going to use for oxygen? Because they breathe oxygen. Yes, they do. Through the gills. Of course they do. Well, then the fish don't have any oxygen, so they're going to die. And a lot of the other aquatic air breathers in your little ecosystem here are going to die, die, die. And then they pretty much they degrade. And as they degrade, the water quality goes down. But then you also get something called blue-green bacteria. In news reports, they always call it blue-green algae. They are not. They are cyanobacteria. So think cyanosis, they're blue. And they live in water that doesn't have oxygen. They're anaerobic. So they will take over. And if your pond looks bluish and stinks, well, that's because it's dead and full of cyanobacteria. And cyanobacteria, as well as some algae, by the way, will form very toxic materials and will kill, again, your fish are going to die if there's anybody left. Your amphibians, like your frogs, are going to die. And of course, never let your cows or your dog drink out of such water because it's toxic. Okay, so this is all eutrophication. All right, what about pesticides? Of course, we use a lot of pesticides. We use them in our yards and in our gardens, but yes, for agricultural purposes, we use a lot of pesticides in this country. So, just a little introduction. What is a pesticide? It's any chemical used to kill pests. And usually the active ingredient is supposed to kill the pest and not everybody who's innocent, that just happens to be exposed to it, ideally. But that is very hard to do, and here is why. Most pests are going to be, well, let's say if you have insect pests, all right, or worm pests or something like that, or rats or mice. Now, they are animals. And guess what you are? You're an animal. So trying to find a poison that only hurts them and doesn't hurt you and your livestock and your pets is very, very tricky. Even for those kinds of chemicals that, I mean, they're actually very cleverly designed, but you have to be very careful about the dose no matter what. Even if it really does tend to target the pests more than it does us, it still can almost always be toxic in high doses. Okay, and it must be treated very carefully. So, define a pest. Well, that's a hard one. So, we tend to think, okay, bacteria, we tend not to categorize those as pests necessarily. Anything in microbiology, we tend not to really consider as a direct pest. But okay, so you have your mice, you have your rats, you have insects that eat your plants, that infect infest your house, all of these things that you just plain don't want. Okay, that is a pest. Okay, so let's talk about the different kinds of insecticides. There are, first of all, inorganic compounds that are insecticides that will kill insects. And by inorganic, that means, okay, they're unique. They tend to be very synthetic, not anything natural. It was probably created in a lab somewhere. And the biggest one of all would be the biggest group are the organochlorine insecticides. And the biggest one of that one is our DDT friend. In addition to DDT, there's also chlordane, aldrin, dieldrin, I think is how it's pronounced. Heptachlor is another one. These tend to be, the organochlorines, they tend to be nerve toxins. Now, supposedly they do have low human toxicity, but okay, but what if they bioaccumulate? And guess what? These things do. So they're very persistent in the environment, and you get enough of it. And even though your original exposure was a low dose, in time, this accumulates in your tissue and it can become now a high dose. So very, very dangerous. Okay. Many of the organochlorine insecticides have been banned in the more developed countries, and this was due to something called the Stockholm Convention. Yay, but not worldwide, and they still sneak up every once in a while. What about another category of chemical pesticides? Well, there are the organophosphate insecticides. And these are also nerve toxins. The good thing about these, I guess, is that they're not persistent in the environment. So they do tend to break down and they tend to not bioaccumulate then, which I guess is a good thing. Over here, it just shows what happens when you have a nerve cell that's supposed to be sending a signal, like acetylcholine signals to another nerve cell, and it gets blocked by these nerve toxins. And that's what a lot of pesticides do, by the way. Most of them are nerve toxins. Okay. And as far as the organophosphate insecticides toxicity towards humans, well, some people are extremely sensitive. It doesn't take a lot of exposure, and they will have some serious side effects, and some people are not affected, at least in an obvious manner. Okay, there are also the carbamate insecticides, and these are really, really close to the organophosphates. And these are supposed to have, again, low acute toxicity to people. So there you go. But again, still a nerve toxin. It's close to the organophosphates. Here's a little something from about the organophosphates and where they originated. These are, again, common, but they can be deadly. And like I said, some of them can affect people in a very different way than other people. So these were first developed by the Germans during World War II. And it wasn't to say howdy do and help the other countries' farm production. No, it was used as a neurotoxin. So now, these pesticides were blamed for killing at least 25 children in India who were not educated very well about its use. And there are a lot of horror stories, by the way, coming from some of the under-resourced countries who are given these pesticides and not being well educated. There, oh gosh, there was one that had this woman mixing up some very toxic pesticides, and I don't have the picture, and so I can't tell you what the pesticide was, but she was mixing it in the cups that she used for basically for drinking purposes, for food purposes. And I just cringed when I saw that picture. But again, a lot of the problems occur because uh, people are given these toxic materials, and they are not educated, and they're not given the personal protective equipment that they're supposed to have. Um, so again, these 25 children in India, were died, and again, they're blaming these pesticides. Um, and again, this actually comes from National Geographic. And in the United States, I think there should be probably a bigger, and maybe somebody needs to evaluate the situation and the use of these pesticides a little more closely. And by the way, I am a tea drinker, and they are spraying tea leaves. So may I suggest, if you are also a tea drinker, you might want to consider the organic kind. Just saying. Okay. Okay, what about another group of insecticides? Well, how about pyrethrum? Pyrethrum actually has, these chemicals actually have an interesting history. If you're wondering why the pretty mums, okay, well, the chemical came from chrysanthemums or mums. As fall approaches, you're going to have all the pretty colors of mums. But yeah, it turns out that mums have a natural chemical that repel a lot of pests, insects, okay? So there are chemicals that were made that are similar to pyrethrum. They use the chemical, and then in the laboratories, they would tag on little side chains to the chemical, and they made pyrethroid types of insecticides. So anything oid is like, so it's pyrethrum-like insecticide. And again, when it comes to the insecticides, they're supposed to have a lower acute toxicity to people. And this is something that you can actually get over the counter, so it's used in a lot of consumer products, but it's also used widely for agricultural purposes. Okay. How about herbicides? Something to kill the plants. Oh joy, let's do that. So herbicides, there are many different kinds of herbicides. Some are very selective. So the selective herbicides are the ones that are only going to kill a particular kind of plant. So for example, let's say you were trying to grow grains, which are grasses, then you don't want to use an herbicide that will kill grasses, but maybe kill all the broadleaf plants that might be growing up in between the rows. So you would use a selective herbicide for that one. And again, you don't want to kill the grass family, like the grains and turf grass, but you do want to kill the dandelions. So there you are. Here's a before and here is an after, but the grass is just hunky-dory. Okay. And by the way, some of these herbicides were used to kill an awful lot of plants during certain military actions. You might have heard during Vietnam, there was something called Agent Orange because it came in these big orange barrels. And a particular kind of selective herbicide was 2,4-D. And so if you don't know what Agent Orange is, it was rather, it was widely spread to defoliate the forests so that soldiers could see anybody hiding because it was a type of guerrilla warfare. So the Vietnamese would be hiding in the shrubs and the greenery, and it was a good camouflage. So what they would do is they would kill all the plants, and that way everybody was a little more visible. And unfortunately, this was sprayed so commonly that we know a lot of our veterans were exposed to Agent Orange. And it had more than, Agent Orange had more than 2,4-D. It had some other chemicals added to it. Okay, little bit about 2,4-D. Okay, so you can still, 2,4-D is something that we did use commonly in the United States, and it's still out there. But, typically you're supposed to use 2,4-D when nothing else works. But here's the problem. Research, again, we've found a lot of evidence to say that it is an endocrine disruptor and even suppresses the immune system. So it's an immunosuppressor. It's not classified as a human carcinogen, but yet even though it's not classified as that, we know that if a rat has been fed enough of it and been exposed over 2 years, that it is a carcinogen. But yet it's still not considered a carcinogen to humans. And by the way, the production of 2,4-D is the 7th largest source of dioxins in our environment. If you remember that one. Okay. Okay. How about something else? How about a non-selective herbicide? Something that just kills all plants. Have you ever used Roundup and you just hope that it doesn't get loose, like you don't have a gust of wind and it gets on your roses or on your potatoes or tomatoes? You're like, oh no, don't let that happen. It's interesting. Roundup is a chemical, and it seems like it would be so very deadly. It's actually a very clever chemical that knocks out an enzyme in plants that is involved in photosynthesis. So one would think, okay, well then it's going to be harmless to humans and animals, our pets, our livestock, the insects, the pollinators, and things like that. And at low doses that seems to be true. But we do know that there is, in high concentrations, there is some toxicity even involved with Roundup. Roundup is produced by Monsanto, and it is known to kill, again, it's non-selective, so it's going to kill both the grasses as well as broadleaf. And here's an interesting thing. You probably have heard of Roundup Ready genetically engineered plants, right? Okay, so there's Roundup Ready corn and especially Roundup Ready soybeans. So we're going to talk about genetically modified organisms, but what is this exactly? Well, a little bit of history. So years ago, farmers were spraying Roundup to kill their weeds, especially in the ditches. And more, no matter how many times they would try to poison some plants, there would always be some plants that were resistant to this chemical. Sounds a little bit like bacteria resistant to antibiotics, right? You get enough of a gene pool, there's somebody somewhere that has a gene that gives them some resistance to a poison. And this is true. And as weeds can reproduce very quickly, okay, it doesn't, it's not too hard for them to provide one little mutant strain of weed, and one of them is going to be resistant to this chemical, this poison known as Roundup. So Monsanto started to look at this, and they said, it'd be so cool. Let's take a gene out of the resistant plant, the one that just kind of the mutant that sprung up. Well, first of all, they had to find the gene that made it resistant. And then they would give it to like their soybean plant seeds or to their corn seeds. And the corn and the soybeans then would grow up and not be hurt by Roundup. So you could spray the whole field with this very non-selective herbicide. So it kills everything. Grasses and broadleaf that are weeds, but leaves your crops behind. And this is the idea behind it. So a Roundup Ready plant, okay, will survive. If anything else dies, and there you go. Okay, so we've talked about pesticides that control insects, pesticides that include that control weeds. And by the way, the only difference between a weed and a plant is that a weed is something you don't want. So if you were growing dandelions for dandelion tea, dandelions are no longer a weed, they are a plant and actually a crop. So there you go. What about other potential pests in agriculture? Well, here we have some peaches, and clearly they have something going on. And so this peach has a fungal infection, so you have to use a fungicide. And those are commonly used, and I won't talk about the side effects of fungicides, but they're very similar to a lot of the other herbicides and can have, and as well as, in fact, some insecticide side effects. But we'll talk about peach orchards later on. What about if your problem is a rodent? Well, then you need a rodenticide. Most of the rodenticides include some kind of bait that contains a chemical that is an anticoagulant. What does that mean? So if you have mice or rats that are, or some other rodent that is in your grain bin or out in the field destroying your crop, you would feed it, throw out these little feed bait, chips or chunks or what have you, and the animal would bleed to death. Now, the problem with this is that what would happen if, well, if another animal came along and thought it looked good, or even a child or a pet or something like that. Or for those of you who know someone who likes to hunt pheasant, and in my family, pheasant hunting was always a tradition in October, but the pheasants would also think that this was something to eat, and they would bleed to death. So this is really kind of a nasty way to control rodents. It just is. I don't know what, there are some other options that we will talk about. What about some limitations of pesticides? Well, we've already talked about some. And again, no matter what, uh, when you try to poison a population of living things using a particular kind of chemical, will always be some mutant in that gene pool that is going to survive. So, and this was actually a Roundup resistant plant. Another name for Roundup, by the way, is glyphosate. Sorry. So, this just shows the pattern of evolution of plant resistance to Roundup or glyphosate. So you can see in 2002 we had some some states that saw Roundup resistant plants, and it didn't take very long to see some fully resistant, completely resistant types of Roundup resistant plants out there. It never takes very long. And if you sort of forgot how this all works for, with antibiotics and bacteria, well, let's also look at what it can do with insects, not just weeds, but insects. So again, let's say you have a bunch of insect pests and they're eating your plants and you spray them. And you have a few that survive, again, genetically here and here. Well, then these are the ones that are going to be resistant, and you can spray and spray and spray, but they're going to consistently be resistant, and you're going to have a bigger and bigger population of pesticide-resistant pests. Okay, and there you go. This is just natural selection. And if you have any kind of gene that makes you a little more able to survive, you will pass it on to your offspring. So later generations will become more and more resistant, and there will be more and more resistance in the communities. Okay, here's some other problems that might occur with the use of pesticides. Sometimes what might happen is you get a target pest resurgence. So, okay, so let's say you kill a pest, okay, that is a predator of another pest, okay? And let's say you're only spraying for that particular pest. So once you lose this, again, you lose the predator, then all of the insects or whatever the prey it's supposed to eat are going to explode. So again, let's say you were spraying for, let's say this was your target pest here, which is the natural enemy of these guys. So you spray them, these guys die. Then you're going to have an explosion of everything that all the pests that they're supposed to be eating. So it causes quite the resurgence. Okay, so maybe you just thought these were the bad guys, but now you have an overpopulation of whatever it is they're supposed to control. Then there's also the accidental killing of the predators of a target pest. So let's say as you're spraying just willy-nilly and it's supposed to kill all your pests, but maybe not everybody dies. There's maybe a few pests that are left. Well, but you probably wiped out their predators. So sometimes you do it intentionally and sometimes you do it accidentally, but you cause a very nasty imbalance in your ecosystem. So, get rid of the predator and the prey is going to just take over. That's all there is to it. How about human health effects of pesticides? As you can imagine, we already talked about that, and I know you're intuitively, you know that this might be a bad thing. So, the problem is that the effects of pesticides are really difficult to study because even if you know, okay, the name of a particular pesticide and it has certain active ingredients, but occasionally they will mix it with other ingredients. So the formula, the recipe for certain pesticides will change from time to time. And also, if you were exposed to one pesticide, you're probably exposed to others. And therefore, it's very, very difficult to study, as far as exposure, of course, as well. So here you have some migrant workers, and they're producing a fog of probably, I'm hoping it's an herbicide, but it almost looks like a pesticide the way they're spraying it. And they have no personal protective equipment. And this is bad. Okay. So again, they change the companies that make these pesticides change the mixture of chemicals. Workers lack information and they become exposed to these chemicals. And there's a whole bunch of different ways to practice protection for workers. Sometimes people are really given good personal protective equipment, sometimes not so much. And let's say you have some people who have, it's hard, well, it's hard to know if you're getting an acute set of symptoms because exposure, or it's something that is occurring years and years later. So maybe you were exposed, in your youth when you were working in the fields, and then it comes a little bit later on. So very hard to know if this was a recent exposure or it occurred years ago. We do know that a lot of pesticides do cause neurologic and reproductive problems, and a lot of them are carcinogenic, and we do know that. I have this picture here to show that it can also, as far as disposal of these pesticides, can be very tricky, and farmers are supposed to, you're never supposed to have an empty pesticide bottle around. That is actually very, very dangerous, and so that's actually illegal to have that, but still illegal dumping of barrels and containers containing pesticides can be found throughout the world, which is sad. This is just one of the world's largest production facilities of pesticides. And oh my goodness. So whatever it is they're churning out, this gets spread all over. It's got to go somewhere. Okay. And another effect, another problem is, all right, again, the innocents that are there. Bees and other pollinators are very beneficial to humans and for agriculture. A lot of crops require bees and other pollinators, and we're losing a lot of our bee population. People want to blame it on a lot of things, and I'll talk about bees and GMOs. We don't think that GMOs have the impact. We think it's the pesticides. actually, and loss of habitat. So what you might want to do is go out and plant some bee-friendly plants, okay? And by the way, it's also your bats are also very important pollinators. So that's a very sad, unintentional effect of pesticides. Let's talk about DDT again because, golly, this is the most infamous of all insecticides. And I know I've mentioned it before, and you saw this picture in black and, well, maybe it wasn't this one, but this one's in color. And here's a big fog of insecticide material coming out of this truck. Understand, though, people really thought DDT was all that. Here's a little something that was advertised for farming communities. DDT is good for me, and they're all singing a happy little song about this insecticide. The inventor, the chemist who developed DDT. Paul Mueller got a Nobel Prize in 1939 about the use it with this stuff, and it was mass produced, which made it a very cheap product. And at the time, they thought it was great that it was long lasting in the soil and the water, and gosh, so then a little bit might last us forever. So good, good, huh? Well, and in World War II, our veterans were sprayed with this stuff to get rid of lice, and body lice would cause diseases such as typhus, and you could get a lot of other diseases as well from lice. And if you had fleas, hey, it would do that for you as well. Southern Europe and North Africa and Asia were all about clearing out mosquitoes. Well, mosquitoes are very big vectors of all kinds of diseases. Bacterial diseases, protozoan diseases like malaria. So, okay, kill the mosquito that spreads these horrible diseases. And that would also allow our troops to be healthier. So, yeah, we spray DDT widely through Europe and Africa. And in fact, in 1955, DDT was core in the Global Malaria Eradication Program. Okay, the World Health Organization was saying, yay, DDT, so it was spread everywhere. So when did the madness stop, you ask? Well, some years ago, a little book came out called Silent Spring, and it was written by a naturalist whose name was Rachel Carson. And okay, this is just showing you how her information was not widely appreciated by an awful lot of people. So the military, the chemists, and people who were using this very cheap chemical to stop the spread of certain infectious diseases, vector-borne diseases, okay, they weren't happy with her. But it made the bestseller list in 1951. And so this was, oopsie. Okay, I didn't mean for the rest of this to come up, but it did. So in Rachel Carson's Silent Spring, she was able well, there was the observation that this DDT chemical would bioaccumulate. It didn't break down, as some chemists already knew, and it was consistently found in the environment. And we know that it's lipophilic, by the way. So again, it is in the tissue of animals. So if you sprayed this, and so you have insects that are full of DDT, and then they're eaten by bigger animals that are eaten by bigger animals that are eaten by bigger animals, and which could be either humans or this poor thing, our bald eagle. Okay, it could have some very severe health issues, right? Health effects. So, and by the way, after abusing DDT for years and years and years, remember it was cheap and everyone loved it, and so everybody used it. What do you think happened to the pest and insect population? Absolutely, they became resistant. So there's still a lot of insects and pests out there that are DDT resistant. Unfortunately, the bald eagle was not. And we started to lose a lot of our bald eagles, and that's when then Americans got very upset And this is when legislation started to change. And in 2001, something called the Stockholm Convention on Persistent Organic Pollutants banned DDT. Okay, but unless there's always a little side note, a little caveat. If you are in a community and there's a big malaria outbreak and you don't have a lot of money, I guess you can still use DDT. And it's still out there and it's creeping up, even though it was officially banned. A lot of people are saying, but this is a last kind of last resort. Sorry, that should be last resort. And so 19 countries are still using it. People are spraying it inside their homes, their huts, to control insects. And this is especially common in Africa. Not good. So this is just showing you when we started to see some problems in the United States. And in 1967, the bald eagle was officially declared an endangered species. How very sad, huh? And the shells of the eagles were so thin and fragile that the hatchlings never survived. Luckily today, we are so excited that the eagle population is back in full force because the United States did ban DDT because we love our national bird. And if you were ever around an older person who gets very, very excited when they see bald eagles overhead, or when you get to see a bald eagle nest, and they're nesting usually, oh gosh, in the late winter, very early spring, we get excited about this because in our day, we thought we were going to lose these birds. Okay, so we get excited for a very good reason. And this is something to be very proud of. We were able to stop this, and our birds are back, and they're so cool, right? All right, so and DDT, if you kind of forgot about it, stands for dichlorophenyl trichloroethane. I know, that's the $1,000,000 word. We do know it is an endocrine disruptor in all animals. We do know that following exposure to high doses, human symptoms can include vomiting, tremors, shakiness, seizures. Lab animals have shown some severe adverse effects on the liver, causing liver damage and reproductive problems. So, and we've seen that with the bald eagle. DDT is considered a possible human carcinogen. And this just shows this is how the biomagnification occurred. You had, so let's say you had the DDT that got into the water, and you have maybe some algae here that is eaten by zooplankton, which is eaten by small fish, eaten by larger fish, which is eaten by our bald eagle, and also by humans. So there you go. Little bit about malaria in Africa, I should let you know. It does turn out that if you use bed nets, it is really, really a good deterrent for mosquitoes. Now, I will say, though, not everybody in Africa can afford a bed net, and that is sad. The best bed nets are sprayed with other insecticides, not DDT insecticides. But if we could, if we could get everybody in a malaria infested environment, get them a good mosquito net so that they could sleep under the net and be protected at night. Well, that's when the female mosquitoes, are feeding, and that's when they would spread malaria. We do know that when we've done this, we've reduced mortality in children by 25 to 40% just using bed nets. Okay. But unfortunately, it's still a problem. Not everyone can afford it, and they tax bed nets, and even in charitable types of programs, they always want to charge people in these communities. And I know it was to stop abuse. People would collect the bed nets and then sell them for a profit, but it's just something that maybe we need to revisit. Also, just a little side note, eliminate standing water. The Panama Canal, when the Panama Canal was being dug, one of the biggest problems was malaria, and of course being spread by mosquitoes. All right, what could you do? Well, so you could get rid of the standing water that mosquitoes breed in. That's where the little larval stages have to remain. They have to be in water, and they don't survive in running water. So, by the way, when it came to the people who were digging the Panama Canal, 80% had malaria, and they did an awful lot of work trying to prevent the disease. So, by just eliminating standing water and also incorporating bed nets in a few cases, they were able to bring the rate from 80%, sorry, down to 7%. So, just get people a bed net. Okay, so let's talk about the use of chemical pesticides in the community and who's exposed to the pesticides and the disparities in exposures and that in the impact. So, okay, who's going to be most exposed? Well, of course, anybody in the field, any worker out there. So, if you're manufacturing pesticides, you're at risk. Hopefully, you're wearing your personal protective equipment and you're getting all the information that you're supposed to have to protect yourself. If you're a farmer, okay, and your family, you might be out there spraying, or you just might, if you're crop dusting, some of the fogs could land in, closer to home if you have the windows open. Sometimes you might be outside during crop dusting operations, so there's a risk there. If you're out spraying, okay, again, you should have your personal protective equipment. You should be following all the directions. If you're a hired farm worker, okay. So most of the hired farm workers in the U.S. are men. About half are Hispanic, the other half are foreign born. Sometimes if they're working in farms, they are not given adequate personal protective equipment. Sometimes they're not working in a safe environment at all. Sometimes they're not even given the warnings. All of these people, sometimes they're because it's invisible. They don't realize it's going to be a problem. Some of them will even wear their clothes home to their families, and so their families are exposed because the clothing is exposed. So, this just makes me cringe. It does. It's very sad. And especially, if you are a migrant worker and maybe you're not documented. So, are you really going to get all upset at your employer? No, you're going to keep your head down and, you're probably not going to complain or ask questions. So, it's especially very sad in those particular communities. Again, in lower income countries, a lot of times there are chemicals being used that we have long since banned in the United States and in other developed countries. Yikes. But, ask yourself too, if we get the food imported from those countries, the vegetables and fruit, what kind of pesticides will we find there? So be careful. Um, Speaking of disparities, there's a particular case study from Lake Apopka, Florida. And Lake Apopka was sort of a dumping ground. There's a lot of field runoff from the 1940s to 1970s. Lots of pesticides were dumped into the lake. Now, what you should know about the lake is before the 40s, it was a bit of a fishing place. I mean, they even had a little clubhouse and they had largemouth bass, and a lot of people would go there to fish. Well, that stopped. Okay. Pretty much the fish died and birds died, and the people working in the community and in the fields started to get sick. And yeah, that means they're not going to survive for very long. This actually was a Superfund cleanup site in the 80s. So if you remember the Superfunds, and it was deemed one of the most toxic and hazardous places in the country. In 1999, the Apopka area experienced a sudden and large-scale death of birds. There was an investigation, by the way, costing millions of dollars, and it was investigated by the U.S. Department of Fish and Wildlife, trying to find out why the birds are dying. Well, probably people in the community could have said, I can tell you. So it turned out, guess what? It was the pesticides. Duh. There was also another study that was out there looking at, oops, sorry, another study that was asking about why the alligators weren't healthy. And again, hundreds and thousands of dollars looked into that in research dollars. And guess what they found? Oh, yeah, must have been the pesticides. So you can imagine these people working in the field and in the community who are experiencing some very nasty effects. I mean, they had a very high rate of many health problems, including lupus and cancer. And they were fighting just to get some kind of medical help, maybe a little bit of financial support from the state, or at least from the community. But never got it. To this day, these farm workers are still trying to get some kind of government attention just to, just to pay their medical bills and to keep them alive. But they were working amongst all of these pesticides this whole time. And you can Google Lake Apopka and you can find out the whole story. But it's like, okay, everybody, and of course, I'm a biologist. I love the birds, and okay, I'm okay with the alligators too. But hello, look at these people who are making, who are trying to provide food for the country. These are Americans out working hard, and no one's spending any money on them. And they're very sick there. Okay, not surprising. Um, but back to this. But as I said, remember, it's really hard to pinpoint cause and effect when it comes to pesticides. So they're having a hard time proving it, and trying to get money out of people sometimes is very hard, right? Okay, let's talk about pyrethrins. So yeah, these are the ones that the mums, right? So these have been widely used for thousands of years. So I found this online. It was very kind of cute, and I had to share this with you. So the Chinese would crush chrysanthemum plants and use the powder as an insecticide as early as 1,000 years BC, and even in the Napoleonic Wars, French soldiers were using the flowers to keep away fleas and body lice, which is so cool. And interestingly enough, it does break down rapidly in the environment. This is something I found online where somebody said you can make your own home remedy of insecticide. So I thought that was kind of interesting. The problem is, even with this, and this seems quite nice, but even when something is natural, you have to be very careful because a lot of our very toxic, there's a lot of toxic materials out there that are natural. In fact, some of the most deadliest chemicals are natural. So we need to be careful. Okay, and understand that bees are harmed by pyrethrin. And even in small doses, as small as 0.02 micrograms, that's teeny weeny. The weight of I mean, well, gosh, couldn't even tell you, use an analogy. Let's just say that's small amounts. One of the things, though, that can be done if you did need to spray with pyrethrins, they recommend that you apply it at night, and that would avoid most of the pollinators. And try to do it as a liquid. Don't dust it, throw it in the air. Try to keep it low as best you can. So, poor little bees. Okay, and again, pyrethrins are neurotoxins. And in insects, you know, you have your pests, and then you have the innocents, the ones that are so important. I just bought some bee honey actually at the farmer's market this weekend, so nice little bees. And know that there are plants that are natural repellents, so lavender and chives and chrysanthemums and rosemary. So all of these things are natural insect repellents, or contain natural insect repellents. Just a little interesting note here. And my aunt who just passed away actually was an amazing gardener, and she always kept the insecticide plants around. She just kind of wove them in and out. And again, diversity. If you have a diverse population of plants, well then, yeah, you're going to repel insects, right? Keep them away from the other plants that maybe you're growing that the insects would normally try to get to, but not with the repellent plants. So kind of interesting. And speaking of that, let's talk about integrated pest management. So integrated means we're going to use multiple tactics. And this is a very interesting approach if done right and well. Sometimes there are abuses here. People will say, oh, we use integrated pest management. When really they're just kind of looking for bugs and okay, yeah, it's time to spray with a lot of pesticides. But if you do it right and you're consistent with ecological principles, you can really do a good job, okay, of managing pests without destroying your ecosystem. Okay, so it is management. So it means not wiping out pests. It means keeping them down, keep the numbers down. So perhaps use natural enemies, maybe the natural predators. So owls. I love owls. And okay, and they do eat rodents. So, make a nice habitat for your owls. Don't keep cutting down trees. So make them happy. Here we have a ladybug, ladybird bug, and she's eating aphids. And a lot of people will buy ladybugs and praying mantids and things like that to get rid of a lot of their plant pests. Okay. And there's some other things that you can use. You can use pathogens and other competitors. And I'll talk about that a little bit later on. How about mechanical and physical controls? So here in her garden, next to some berries, so she has sort of the equivalent of flypaper, just keeping the numbers down, keeping them off the leaves. So there you go. And okay, there are different kinds of mechanical traps for rodents. And okay, there are live traps, but for mice and rats, people usually don't. Usually they want them kind of dead. So, but at least if you kill them in traps, at least they're not being eaten by other animals and your predatory birds, that sort of thing. You can also steam sterilize the soil if the soil has a lot of fungal organisms or bacteria or something or worms that you don't like. That's a doable thing. And again, yeah, traps for insects and rodents. Mulch. Mulch kind of smother the weeds so they can't get any sunlight. So that usually works really well. Use barriers such as screens to keep out your birds. We don't want to hurt birds. Keep the insects out. There's a big push towards indoor growing, not just in places like Europe, but also in the United States. This is called vertical farming, and it's actually headed by a parasitologist, interestingly enough, from Columbia University. And his name is Dixon Despalmier. And Dr. Despalmier, again, his life has mostly been the studying parasites, but he got involved in vertical farming. So if you Google vertical farming, he's one of the major advocates of this process. But it's a way to control pests, to manage water, and so okay. And here you don't need your pesticides, and it's going to contain your water, and you're going to have really pretty plants. And you can do this in the middle of an urban setting. And that's what he's trying to do. Okay. So I just wanted to mention that. Pheromones. So this would be pest hormones that would attract the pests and then maybe get them, they could get stuck in some kind of fly paper or some solution. Change irrigation practices. So for example, if you irrigate in such a way that the roots have a little bit too much water unnecessarily, well, that's going to encourage root rot. So don't do that and change your irrigation practices. Crop rotation is a very interesting method. So, for example, if you have a crop in your field and okay, it's going to attract a certain kind of pest that likes that crop. Well, okay, and as they're starting to get a foothold, about that time, okay, when the season's done, plant something else. And then, oh, yeah, well, okay, they're not going to like that particular plant. So, okay, so you probably will have some other pests that will get there, but they won't be in huge abundant numbers. So, and by the way, crop rotation also is a very good way if you do the corn and soybean crop rotation method. That will also help to put natural nitrogen back into the soil. So, lots of good benefits of crop rotation. And I love this. So, chickens. My brother loves chickens. I have to admit, growing up in the farm, like I said, now my brother didn't spend time on my uncle's farm. I did. So we had eggs for breakfast, chicken for lunch, and chicken for dinner. And oh, yes, we did the slaughtering of chickens. And there was a particular rooster that hated me. It took years for me to like chickens, whether as a friendly little animal or even as a food. But I like them for both now, as long as they're raised humanely. But you know what? Chickens love bugs. They do. They just love going through and they love munching up little bugs. And so I love that they're just kind of looking to see if they can find any bugs. And again, you can grow particular plants that will, of course, this is monocropping, but you can take this and plant the mums in your garden, and this will help to keep some of the pests down, the weeds, right? So when it comes to integrated pest management, usually what they do is they set some kind of threshold. You have to monitor and say, okay, we can tolerate this many plants or this many pests, and we'll look for certain amounts of damage. And then, okay, if it gets to a certain level, a certain threshold, then it's time to act. And maybe add the chemicals at some point, but only when needed. And again, only in combination with other approaches. So maybe use be mindful of what you're using and how you use it. So we know that this is very effective and it's good for long-term control. You can use pesticides that minimize possible harm to people, something that doesn't target the good organisms and other things in the environment, doesn't maybe leach into the groundwater the way you're using it. Um, like I said, use maybe pesticides in bait stations rather than sprays. So fly paper that has a pesticide in it, or spot spray a few weeds instead of going through and just hosing down the whole field. Um, it's a little harder to integrate into large scale, but it can be done. Okay. And there's your assignment this week tells you that, yeah, it can be done if done properly. And maybe we do need maybe some more studies, but yeah, it can be done. I just wanted to show you my uncle's farm's version of a herbicide, specifically thistle control. No, this isn't me. I found this online. There is no picture of me as a 14, 15-year-old out digging thistles in Norfolk, around the Staten, Nebraska area. But yeah, so my cousin Patty and I, she's a nurse now, and she and I would be out there digging thistles in a field pasture all day long. And we go from field to field to field. And about the time we finished the last field, yeah, the other fields were all ready to be worked on again. So this was, again, no child labor laws in the farm, but we had a good time. I really did. So, oh, and this is what we did to get rid of potato bugs. So we used a little bit of chemical kerosene actually, to control potato bugs in my uncle's potato garden. He didn't have a big potato garden, but it was fairly sizable. So here's a potato plant, and here are the potatoes, and there are things like potato bugs that are on the leaves. Okay, so this is controlled use of chemical pesticides. So the chemical would be kerosene in a bucket. You're like, okay. And what you would do is you would have, with one hand, you would hold the bucket full of kerosene, which is toxic, but you were careful with it. And then in your other hand, you held a stick. And then you'd whack the potato bush with the stick, and the potato bush would be okay, but the potato bugs would go flying into the kerosene. So that's what we used, and boy, did my back hurt. Think about going from plant to plant to plant. Again, no child labor laws. I want to talk about some other integrative management of pests. And this one actually uses something biological. instead of a stick and a bucket of kerosene. So this is a peachy keen story. If you've never heard the word peachy keen, it's an old term. Old people know it. Just means really, really nice. Okay. So, all right. This is how the biofungicide called Serenade was discovered. Now, years ago, there was a California peach orchard, and some California, well, I guess that, well, they were UC Davis students that went out to figure out why this peach orchard was not being destroyed by a fungal infection. So this is called brown rot, and field after field, field after field after field of peach trees were being destroyed by this fungus, except for this one gentleman's his peach orchard was untouched. So the people from from UC Davis went out to figure out what was unique in his soil, in his leaves. They tested everything, and what they found was in his soil was a natural soil bacterium called Bacillus subtilis, very subtle, a particular strain of Bacillus subtilis. And it was found in the soil. Okay. Now, we know that this organism, when it's in the soil, will outcompete and stop the production of all kinds of fungal infections. So so if you have vegetable crops or any kind of tree fruit or nuts or vine crops, we know that spraying Bacillus subtilis in the soil will actually stop the fungal infection, or what's called brown rot, okay? So they did about 700 field trials on all kinds of crops, and not just peach trees and things like that, but just about every kind of crop that they could possibly think of in California was tested, and it worked. So they have actually Serenade Garden disease control is actually approved by the EPA and USDA's National Organic Program. So again, this organism just outcompetes the fungus. So it's stronger, and it's a natural, something that's normally found in the soil. And you just spray it in the soil, and the peaches come out without the brown rot. What do you know about this? So again, just a little bit about Bacillus subtilis. It's very hardy, these bacteria. They make something called spores. If you remember spore formers and how tough they are, yeah. But these are not disease-causing organisms. Again, they're soil bacteria. And when you apply these things to seeds, it colonizes and develops in the roots of the plants. So we're not talking about getting even on the fruit. And the bacterium attacks and competes with all the fungal pathogens, including fungi known as Rhizocnia and Fusarium, Aspergillus, if you remember that from my other lecture, and several others. So it's something very, very natural and very tough, and it will live in the root system. So and provide protection throughout the whole growing season. Actually, even Walmart was set to buy. Some of the stores did sell Serenade. And I went to Mulhall's in my area, and they had it, but you can also get it on Amazon. So this just shows how the little bacteria get down, and they will destroy colonizing fungal hyphae. So kind of just interesting how they do that. Let's talk about GMOs, or genetically modified organisms. Genetically modified crop plants? Okay, well, we'll talk about organisms in general, because most of you probably know all of this as being GMOs. GMOs have gotten such a bad reputation in the past, and I'll kind of go through some of the pros and the cons of GMOs. Just before I even start, I should tell you that I have a friend of mine, and she's very good about the food that she selects, and she has some very good arguments, and it's the same arguments I have about being fussy about the food that you buy and ingest. When it comes to GMOs, I'm not as concerned about ingesting a plant or an animal that has been genetically modified. My concern is its effect in the environment and the balance of the ecosystem. So, and I will explain why this is. So here we go. So why GMOs? Why genetically change seeds and genes in these seed plants? Well, the whole idea to start with was to increase global food supplies. And there are certain communities, let's face it, in this world, they do not get enough food. Sometimes they live in areas where there's just, it's not, uh, it will not support the group, the growth of any kind of produce, okay? Any kind of agricultural commodity. So with GMOs, the scientists looked at some plants that were able to naturally repel pests. Well, remember, we talked about chrysanthemums naturally repel pests, right? And some plants will ripen faster, and some are drought resistant. And these, so they said, well, there must be a gene in these crops that survive these challenges. There must be something genetic. And why don't we take these genes, take them out of those plants and put them into a crop plant? And that's the whole basis. So it's not really frankenfood. It's taking a gene from usually almost always another plant and putting it into a new plant. Except there are some other cases we're going to talk about taking a gene from a bacterial cell and putting it into a plant. So, and again, it was the whole idea was it started out very noble, to stop this and food riots from occurring. So to stop that, clearly it seems like a good idea. Um, the problem is that starvation is usually caused by poverty, period. And GMOs are not going to solve that. Government unrest, um, inequity, GMOs can only do so much here. Okay, but let's talk about it. So, GMOs, the first transgenic plants in agriculture. Transgenic means that they got a gene inserted that they normally wouldn't have had. Okay, and geneticists will tell you that, well, we've always kind of selected for certain genes. So you have two small dogs and you mate them to get even, smaller dogs. We did this for crops, and if you remember that from biology, we've kind of done it that way for many, many years. But, well, we're taking pretty fast leaps here. And this does lead to some very severe monocropping, right? So monoculture. So that is one of the problems. But one of the first engineered fruits was a tomato that wouldn't spoil. Well, if it didn't spoil, then it could come off the vine, travel long distances. It would look beautiful, and you'd pay a lot of money, and it wouldn't be rotting. So that was the whole purpose. And also you can have genes for extra sugar production. Maybe look at another plant that makes a lot of sugar and just add it to maybe your tomato plant. Sometimes though, when people were using and modifying these seeds, sometimes they lost the the genes for flavor, I must say. But yeah, so this was one of the very first. This is a flavor saver, sorry, tomato. Um, Here's something that failed, and I'm not quite sure about why they failed this one. I kind of thought this was cool. So there's a lot of people who get a poor diet. And for example, if they eat a diet of rice, white rice, they tend not to have other food sources. Sometimes they have a deficiency in beta carotene, and a deficiency in beta carotene, if it's very severe, can cause blindness. So there's now daffodils make a lot of beta carotene, which is what makes them nice and yellow. So this is something that Monsanto did, and they took the gene from the daffodil, added it to the rice seeds, and they got golden rice. So with your rice meal, you got a little daffodil, a little beta carotene. So, with this one, I never quite saw the big uproar about this one. I thought, well, why not? But this was banned, actually. Um, But there are a lot of GMO plants or transgenic plants in agriculture that didn't get banned. Like I said, they can look at another plant or organism and see that it is heat tolerant, cold tolerant, drought tolerant, pest resistant, weed resistant, salt tolerant, had more nutrition and of a bigger, had a better nutritional value to it, like beta carotene. Maybe it required less fertilizers. Okay. Maybe transfer those genes into the seeds of soybean, cotton, alfalfa, rice, potatoes, and corn. And they did. They did that. So, okay. And again, do we consider that frankenfood? Which is why I really don't, I'm not that concerned about GMOs. There is a couple things, though, again, that is a problem, and I will address that. So, how does this all come about? How do you get a gene from one animal to another animal? Or we call this a transgenic organism. Well, this all happens by biotechnology. Biotechnology is just designing and creating new genetic variants of organisms, okay? So, transgenic plants. How are you going to get a gene from one plant into another plant, or from one organism to a plant? Well, it was a tricky thing. They actually had to use a very special little bacterium that is very good at transferring genes from one place to another. So, Agrobacterium tumefaciens is a bacterium that will invade plants and insert DNA into the plant. And its little DNA will actually usually get inserted into the part of the plant DNA that controls plant cell growth and replication. Because of that, the plant many times will get galls or tumors. So something like that. Now that's extraordinary, but when you Google, you get some of the most crazy examples. But yeah, so Agrobacterium tumefaciens, if it snuggled up to a cell in the plant, it would insert its gene, and again, it would mess with the replication cycle, and you get kind of this tumor. Not, again, it's just benign, it's just there. So scientists thought, well, okay, what if we kind of gut most of the genetic material from Agrobacterium tumefaciens, and they carry a little piece of DNA that can be inserted into the plant, and we'll just tag on our own gene. So we'll let Agrobacterium tumefaciens do its stuff, but instead of inserting its gene into the plant cells, it will insert our genes into the plant cells. So here we go. So here's Agrobacterium tumefaciens, and here's a special little piece of DNA. And with some enzymes, we just take a gene. So again, this could be a daffodil gene from a daffodil plant cell, and insert it into the special little piece of DNA, which, by the way, is known as a plasmid. Plasmid, Plasmid, and insert it into Agrobacterium. And Agrobacterium, every time it divides, it will replicate all of its genetic material and then insert it into a plant, which is what it normally does. So here's a plant cell. Here's a green plant cell wall, so you know it's a plant cell. And the bacterial cell just snuggles up, inserts its DNA. And again, this is the DNA that we wanted inserted. And every time the plant cell, so we can grow the plant cells in culture like this. And if you've ever had a plant that you wanted to root, like you took a little snip off of someone else's plant and you just wanted it to root, plants can do that. So you can grow a whole plant from like this little bit of cell tissue that has been transformed, or so we call it transgenic. And then you get this whole new plant, and every little cell has this little gene that we got in there through Agrobacterium tumefaciens. Okay. So what happens? So Agrobacterium tumefaciens, well, the gene that we inserted, it's doing the funny thing, sorry. So the bacterium, the gene that we have here, will be transcribed and translated into a protein, if you remember your biology, right? So the plant cells, let me move back. So the plant cells will use the gene and it will be transcribed and translated into whatever protein that the gene told it to make. So there's a lot of protein. Or it could be beta carotene. We inserted the gene to make beta carotene, and now the gene will be transcribed and translated. So here's the nucleus of a cell, and here we have a gene being copied and transcribed, into messenger RNA, and then it gets translated at the ribosome into a protein. So we could make any natural protein that we wanted. So our plant is carrying new proteins that it couldn't make before. I'm not worried about the different DNA in the plant, but maybe the protein is something that, okay, maybe that's something that we wanted, but okay. Oh, sorry, this thing is behaving badly. And I think I had this timed and it's not supposed to be timed. So yeah, it's not the DNA being introduced because DNA is just DNA. Plant DNA is just A's and T's and G's and C's. I'm going to turn this off. Plant DNA is just A's and T's and G's and C's, okay? So I put new DNA into our plant up here, no big deal. Okay, the plant already had A's and T's and G's and C's, but there is a new protein that the plant cells couldn't make before, and now they can. Now, the one thing about proteins is proteins can be allergens. You know, some of you are probably allergic to peanut proteins. If a peanut protein can cause an allergic reaction, well, so could maybe the new beta carotene that's being made in our plant. Okay. So it's not the DNA, it's the protein, and there is that potential for an allergy. Do I have any evidence that somebody ate a GMO plant and had an allergic reaction? No, as far as I know, it hasn't happened, but it sure could. So there's a biological reason why we would be concerned about that. So, you know, if you ate a food and you're wondering why you broke out eating this particular food, even though you've had corn, you know, let's say maybe you came from Central or South America and you were eating natural corn from there and it wasn't a GMO, and all of a sudden you had potato chips, corn chips up here, and you had an allergic reaction. Okay, well, maybe it's something, it's one of the proteins that are made in the corn, and all of a sudden you're allergic to that, which is why it's important to know if something's GMO. So you could say, well, maybe it's not the corn, but it's the product that the new gene is making, and that's what I'm allergic to. Okay, hopefully that makes a little sense. If not, email me. I'd be delighted to help explain it. It's hard to do this in this context without a whole genetics lecture, okay? Okay. So, by the way, there are genetically modified organisms that are animals, transgenic. So, for example, in an embryonic state, we could add an extra gene that these fish normally have to make growth hormones. Just give them an extra gene. So extra genes means extra growth hormone, and you get big old fish. Okay? So yeah, just inject growth hormone genes into the embryo and you get really, really big fish. So that's a transgenic animal. And this is done with rainbow trout and salmon. Now, sometimes they use its own genes. Sometimes they use genes from another fish, but there you go. And usually this would allow the fish to grow much faster, and again, this would increase the profit. If you were a fish farmer, your fish would go to market size very, very quickly. Okay, this is interesting. Maybe you've seen glowfish in the pet store. Glowfish have been genetically modified in that they got a little gene when they were in the embryonic state. These little guys, so single cells or maybe 4 cells, they got a little gene from a jellyfish. Jellyfish sometimes normally fluoresce because jellyfish have genes that are transcribed and translated into fluorescing green colors. Okay. So they put the fluorescing green gene information into the fish, and now the fish have the gene, and the gene allows them to make the protein, and they fluoresce. So there you go. Okay, and you can buy those for about $6. Okay, there's one particular genetically modified organism known as the Bt crop organism. It's like Bt corn, you heard of that? Bt soybeans? Let's talk about Bt crops. Okay. So here's the idea. Now, Bt stands for Bacillus thuringiensis. It's a bacterium, lives, naturally in the fields, and it turns out if it's eaten by some caterpillars, like pest caterpillars that normally would munch on your leaves, it will kill the pet caterpillar. It turns out Bacillus thuringiensis makes a natural pesticide. So the thought was this: take the gene in the bacteria that makes the pesticide and insert it in the plant. So now all the plant cells are manufacturing the pesticide, and that kills your pest. Little more detail? Okay. So here's a little guy, and he's a little caterpillar. So most insects come in many stages, and usually they have kind of a worm-like stage like this. And he's munching up crops, okay? And like I said, Bt stands for Bacillus thuringiensis. And again, it's a bacterium that naturally produces a pesticide. So as this little caterpillar is eating the leaf, he might accidentally eat Bacillus thuringiensis naturally in the field. Yeah, just naturally. He could come up and munch up and ingest this bacterium. Now, and this is what the bacterium really looks like. Here you can see it in green. And here's the caterpillar. Here's the caterpillar down here. So caterpillar ingests the bacteria in green and other bacteria. Okay. Turns out the bacteria, and so that's Bacillus thuringiensis. The bacterium naturally makes this crystal-like structure that is a pesticide and releases it. So the little pesticide guys now are in the gut of our pest. Okay. And what this particular pesticide does is that it destroys the gut of the pest, of this larval stage of the insect, what we call a caterpillar. So kills him. And here's a picture of him. So this is the caterpillar. This is a cabbage looper, by the way. Here he is healthy. This is him after he has ingested Bacillus thuringiensis that has made the pesticide. Okay, and it turns out now the bacterial cell, when they release the toxin, they die. But what that does, though, is it lets all of their friends feast on the dead caterpillar. So the rest of the bacteria in the gut have a feast on the corpse. Okay, got that? And again, they don't survive that. So put the Bt gene in the seeds of like soybeans and corn, and they will be very resistant. So scientists have put the gene in there, put the gene into certain crops, again, like corn and cotton and soybeans. Here you can see this is one plant that's been eaten by caterpillars. This one is Bt transgenic. It has the Bt gene. Here we have soybeans. This one's a Bt soybean plant. This one is not. It's been eaten. Again, here we have corn that's been destroyed, and here's the Bt strain. So this is the GMO. Okay. Now here's a thought. If there's enough pressure, there is no reason why we couldn't improve the technology. Do we really need to have every single cell in the plant making the pesticide all at the same time? Maybe we could just have the pesticide turned on during the feeding time of these pests. Okay, and the rest of the year, the pesticide isn't made. Or only have the pesticide turned on the leaves and not on the seeds, like the crop part. Not on the soybeans, not on the corn. So, by the way, this is doable, and scientists do this kind of thing all the time. You can turn genes on and off. I've done this in my own microbiology lab. You can turn on certain genes with sugar. Okay, turn them on and or turn them off. The technology could be developed, but again, there has to be a lot of pressure in order to do that. So maybe turn the gene on, only where the cells are being attacked and no place else, or turn them on only during the feeding time of the insect. It can be done. Now, you're probably wondering, but this toxin, what is that going to do in our gut? So should humans be concerned? Well, here's the thing. Toxins are chemicals like everything else, and in certain environments they work, and in certain environments they don't work. So in certain environments, the toxin won't work. Turns out this toxin is only going to be in the active form if it's in an alkaline environment. An insect gut, so here's our insect, if he eats this toxin, turns out in his gut, he has a very unique type of alkaline environment. So that will turn on that will actually cause the toxin to work. Now, and that is very unique in the animal kingdom. This is not true with you and your cows and your chickens and your kids. The human gut and many other animals, most other animals, have a pH of about 1, so very acidic. It's the other end of the spectrum. So, yeah. So insect guts are about a 10, very alkaline. Humans about 1. So the toxin doesn't work on us. Okay. Now, at least this is what we found so far. But here's some problems, and here again is why I have problems with GMOs. If you have a GMO crop, all your seeds are pretty much genetically identical, and you don't have diversity. Don't like that. Nor do I like the idea that you might hurt something else. So again, there's the innocent bystanders. Okay. So in this particular case, and by the way, a lot of people denied that BT corn hurt the monarch butterflies. And it turns out, yeah, it does. So the pollen that the corn produces does harm monarch butterflies, and Cornell University did several studies of this in 1999. So yeah, this is not good for our monarch butterflies, and those are the only ones that we're even looking at. So we like to look at the pretty butterflies, but there might be something else in the environment that is crucial to the balance of the ecosystem that is being affected by the BT corn, okay? So this is way too much BT toxin that's supposed to be in the environment. This is not, this is not really very balanced, okay? Oh, little warning, by the way. So here's Margaret Roberts, biological caterpillar insecticide, all natural. But guess what she's using? Her natural caterpillar insecticide is actually thuricide, which is, okay, this is the toxin produced by Bacillus thuringiensis. So, ta-da. Other problems that occur when certain communities, farming communities, especially the ones in China, growing cotton that was BT or transgenic, turns out that it caused an imbalance, and something called a mirid bug took off and destroyed the cotton crop. So they were using BT, and it backfired because, again, it took away one of the predators of the environment, and now it left the mirid bug, and it took over and destroyed the cotton. So they're not very happy. Okay. Well, this is one thing whenever I teach biotechnology and we have to talk about ethics, and later on I'll really cover ethics. There's that just because we can does that mean we should, and that'll come up again. But in biotechnology, you always have to think, okay, but what is the alternative? Okay, do I like GMOs? Not particularly. But do I like this? No, I know I do not like this. I don't like just hosing down fields with very nasty pesticides. And I'm not even crazy about herbicides either. Okay, so to summarize about GMOs and its potential impacts, we know that in some cases it's not good for the diversity and of our ecosystems. And even though, well, our farms can't really be considered a natural ecosystem, but keeping a balance has its definite benefits here. So yeah, we don't know if how much of an impact GMOs have, at least right now. We do know that potential proteins are produced that potentially could cause allergic reactions, which we don't like. We also know that pollen from GMO plants can actually be transferred to other fields. And they used to always argue that no, corn crops, corn pollen's too heavy, it's never going to go very far. But it turns out now they've realized, oh yeah, it can. So you might have a non-GMO crop a few fields away, and all of a sudden, ta-da, you now have a GMO crop. So that's not too good. Sometimes it's not controlled as well as it should be. And like I mentioned before, if everything is the same seed from Monsanto or Bayer or what have you, well, you lose your biodiversity. That can't be a good thing. It can. We need as much biodiversity as we possibly can get, I believe, as a biologist. Pluses behind GMOs. Now, when I first started to do this lecture in 2006, I said the world's population has reached 6 billion. Well, we're in 2017, and guess what? The numbers are 7.5 billion. And we have less and less agricultural land. And we don't have our fossil fuels are causing havoc, and and most of the crops are grown needing a lot of fossil fuels, either pesticides or herbicides or for transportation or for something else, but it's heavily utilized. Um, Now, here's the thing, by 2050, it is estimated the world population will probably reach about 9 billion. So will GMOs be the answer to that problem? I don't know. Um, and I'm not really sure if they will. They did start out, people who started to produce GMOs, they started out off with good intentions. And I think perhaps in some cases GMOs are still useful and always will be, but I think they have to be very careful, monitored, and not used too widely. Also, I think that farmers should be able to use any kind of seed that they want to, and they should not be forced to use anything that's a GMO. And sometimes farmers have no choice but to use GMOs or to go organic. And sometimes that's tricky for them to do, especially in other cultures around the world. So again, yeah, trying to grow enough food for everyone. We don't have a lot of cultivable land per person. It's declining. But like I said, though, sometimes, when it comes to hunger, that's a political, economical thing. And I don't know if GMOs are really going to solve all those problems. I really don't. Oh, and again, you also have to, when it comes to GMOs, look at the alternative. Uh, so I don't like that either. The other thing is, there's a big trend out there from some of the big seed producers, the ones that produce all the genetically modified foods, to ensure that it's very difficult to know if the food you're consuming has genetically modified material in it. Okay, so it's very, very hard to distinguish genetically modified foods. And finally, one of the things that I think is very important is I think you do have the right to know, though, for whatever reason, even if your information isn't completely, maybe even accurate, but you should know. You should be able to know if the food you are consuming and your family is consuming and that you are paying for, if it is genetically modified. But time and time again, it becomes a little difficult to know if the food you are consuming is genetically modified. But there are a lot of activists out there that are trying to make sure that all GMO foods are completely labeled. But let me tell you, there are some very strong lobbyists, especially the ones that are selling all of the GMO seeds and the pesticides, like the Roundup for Roundup Ready plants, and okay, the big agriculture people. They're not really crazy about food being labeled as GMO, because that will hurt sales. So, but I think we have the right to know. That's just my take on things. Okay, now your book talks about genetically modified crop plants and the spread of antibiotic resistance. I looked at the argument and I'm not quite sure that is a huge argument. I understand the technology, but knowing what I know about bacteria, and they're talking about a particular gene of antibiotic resistance used in transforming like GMO plants and animals. I don't think that's a huge problem. So if that becomes a problem, then I'm wrong about that, but I'm just going to move on. I just wanted to tell you that, okay, the GMO crops and let's just say that most of the seeds out there are sold by 10 very, very big companies. So you probably know Monsanto, DuPont. There's Bayer down here and Dow, and these are very, very big countries. And they do control the seed market that's out there. And so for a lot of farmers, you get what they give you. And if your corn is Roundup ready, then you also have to buy Roundup to go with that. So you're a little stuck in some cases. It's big, big money. All right, let's talk about agriculture and the use of water for irrigation just quickly. Um, Irrigation takes up about a third of the United States water consumption. And this is a statistic in 2005. Clearly, it's not a good thing. As I mentioned earlier, you get a lot of water loss due to evaporation, and the way we irrigate really encourages evaporation. There are certain areas that we worry most about, and I have actually, okay. So this just shows, for example, like the Colorado River. You can see where the watermark used to be, and it's being drained. So, there's just a lot of things that are draining our major water sources. And we have more and more people who require more and more water. So this is an area of concern. But I'm going to move back to this particular slide because here's this is a graph to show just how much how much water certain plants require. And I don't know if you are aware, but I always feel guilty eating almonds, and a lot of almonds in California, are grown using an awful lot of their very important water resources. So, and alfalfa is even worse still. So I think in certain areas you have to be very careful about what crops you grow. And even though almonds are very good for you, maybe we need to kind of cut down our almond consumption. Seems like every time I look at a granola, there's almonds in there, and I think, it takes so much fresh water to get that almond in that little bag that, there might be better sources for good oils and things. But all right. So, and this just shows again, we do not have unlimited water. We are, grabbing water from aquifers and that cannot be replenished. And we rely on that water for the crops that we make here in the United States. And this just shows the certain crops that are used throughout the United States. And again, water is essential. And not only to grow crops, but also, well, to feed our cattle. There's some real tragic stories about coming out of Texas and the drought down there, and the cattle ranchers who have had to destroy their cows because they just couldn't afford to pay for the hay and the feed and the water for the cattle. So they just had to destroy their cows, and very sad. Okay, let's talk about mechanical hazards to workers. So when it comes to if you work in agriculture, and we talk about fatal injuries, there's about 300 fatal injuries per year in the United States, and that's from 2006 to 2010. Normally, it has something to do with transportation or equipment. If you know anybody that works on the farm, you know there's a lot of people that get hurt on there's always a combine type accident, which is bad, right? And many times it's lethal. The fatal injury rate is only slightly less than that of a coal miner. So very serious in our communities. When it comes to non-fatal injuries, well, mostly farmers are reporting that they get struck by objects or equipment. So, they're not really wearing hard hats out there. Sometimes their hands are, get caught in some of the mechanical work machines. Their feet get crushed. Sometimes because of human error, sometimes because of haste. And that makes sense. It's kind of like every other injury you would think of in the workplace. All right, let's talk about modern livestock production. Okay. So, oh, okay, wow, look at this steak. Nummy, I'm making you hungry right now, I'm sure. What you have to understand is we eat a lot of meat. We never have eaten this much meat. When I was growing up, like I said, on my uncle's farm, we ate chicken and chicken products 3 times. I mean, those were our 3 meals. In my own, with my back in the city, again, every once in a while you had beef, but it was usually ground up with hamburger helper and maybe noodles or something like that because you would make it stretch. But the 1970s is really when we started to produce mass amounts of beef. And a lot of it was attributed to fast food and McDonald's, to be honest, and how we raise our animals. Really eating as much meat as we do in the United States is a little crazy. It's a bit of a luxury and not really necessary, as hopefully I'll convince you of. Um, our modern livestock production is pretty insane. Uh, when it comes to, our feed crops, what we're feeding our cattle and our chickens and our pigs, okay, well, a lot of it requires a lot of petroleum products. Again, what had to go into the feed and the transportation and the processing. So lots and lots of fossil fuels are used to produce meat in this country. And it emphasizes mechanization and large scale production, not something this planet is actually used to. It's used to something a little more balanced. And uses new feeding and veterinary practices. And by veterinary and feeding practices, I'm talking about antibiotics. That's a very gentle way of putting that. And we'll talk about that. Of course we will. In the 1970s, that's when we started, like I said, we started to really roll out the corn-fed beef. Some of you have probably never tasted anything that wasn't corn-fed beef. Probably, you probably have never tasted grass-fed. Corn-fed beef clearly does give you a bigger animal, faster, goes to market faster, and you get more fat in the tissue. That is true. But what you need to know is cows are not designed to eat corn. Okay, they are supposed to eat grasses. And more on this later on, but it's not something they're supposed to be eating. Actually, there's nothing about concentrating animal feeding operations that is natural in any way. Sometimes we just call these CAFOs, by the way. So when it comes to concentrated animal feeding operations, okay, in 2010 in the United States, there were about 34.4 million cattle in CAFOs, 110 million hogs, 8.6 billion with the B chickens all slaughtered, okay, in the CAFOs. Production of beef, swine, and broiler chickens is usually concentrated in just a few states. And this is from your textbook. So this shows where we really see the most, biggest number of CAFOs. And of course, they are found in other places like Nebraska, but this is really where you find huge, huge numbers. Okay. And this is the normal CAFO operation. So again, like I showed you before with the picture, so you have maybe a broiler chicken operation, and everybody's raised in small confined areas, and all waste gets pretty much dumped into some kind of manure lagoon. Yeah, what can happen? What can go wrong there, right? Okay. So the health impacts of CAFOs to workers and neighbors. Well, everybody always says, not in my neighborhood. Recently, there was a big uproar in this particular area because I believe it was, okay, there was a big chicken production plant, a big CAFO that was supposed to go up by Fremont, Nebraska. So, okay, it wasn't Walmart, it was probably Costco. I think it was Costco. Okay, when it comes to working in these operations, well, there's a lot of fatal injuries to workers. And when they're in this operation, no, there's a lot of feces and urine, and it's all over the place. And it gets into the dust, into the air, and the amount of ammonia can just make your eyes water. If you've ever been close to a hog confinement, you know your eyes just start to burn. Well, can you go in there and start working in that stuff? Well, maybe, maybe not, but this is their job. And of course, they have to sometimes work in manure pits. Yeah, that sounds like a lot of fun and perfectly hygienic and safe. Now, if you live next to this and you're a neighbor, oh dear. So there's odors of manure, and if it's by a fishing operation, maybe dead fish, ammonia, hydrogen sulfide, which is going to smell like rotten eggs. And this is where this is where you're going to live. In Omaha, we used to have huge feedlots. And forever, you could always tell when the winds were out of the south because the whole city just pretty much stunk. And it was hard to sell real estate in North and South Omaha because yeah, because everything smelled like cows and urine and hydrogen sulfide and nasty stuff. So, yeah. So when it comes to conditions in these animal confinement facilities, well, when it comes to feedlots, sometimes, the cattle are not going to be on grass, and sometimes they're in paved or just dirt. Kinds of confinements here. So, sometimes other animals might be in closed houses. Maybe they have slotted floors like for swine, so they're standing on like cages. Okay. When it comes to chickens, they'll be in a bedding, broiler chickens. That's what they mean by broilers. And it's usually crowded and dusty and again full of ammonia, and you got to have a lot of ventilation going on because it will kill the animals. So ammonia, hydrogen sulfide, and dust, not only for the workers, but of course for the animals that a lot of them don't get to leave. So respiratory problems are the largest single cause of death in cattle and swine before slaughter. And here you can see some pigs. I'm sorry, it's pretty grainy. Yeah, sorry about that. But the pigs never made it to slaughter just because the conditions were too harsh. I mean, it's just toxic in there. So from our other lecture of infectious disease, so what is the formula for causing a breakout in infectious disease, in infectious diseases? What do you think? So, okay, and again, there are a lot of pathogens that are transmitted by respiratory droplets, a lot of viruses, bird flu, things like that. Okay. So a lot of fecal oral pathogens are going to be, they're going to be transmitted if there's a lot of feces around, not a good lot of hygiene. So let's just look at this. And here you can see some chickens and here you can see some hogs, and you probably know where I'm going. So the best formula for causing breakouts of infectious diseases would be, put animals in cramped, confined areas where everyone's breathing on one another, and you don't, the viruses and bacteria don't have far to go to get to the next host. And if you think that's not a problem, well, if you remember when the bird flu hit, and in this area, all the birds, the chickens and the turkeys all had to be destroyed. And just ask a hog farmer if one infectious organism gets into the hog confinement, they could lose everything. Okay. Okay, so where's the feces going? Oh, yeah, well, there's going to be a lot of fecal bacteria available. So probably on their feet, on their hides, in the air they're breathing. And yeah, it'll probably blow into the feed that they're ingesting. So that wouldn't be a problem. If you are cattle, you might be wading in a big old manure pile like that. So, and okay, because you are stressed. You could be stressed out because, well, okay, you're in a horribly confined, awful area. And poor diet will also make you very predisposed to an infectious disease. Remember what I said about corn and corn-fed beef? Cattle are not supposed to eat corn. Uh, for feedlots, though, it is very efficient. The way that we raise cattle, indeed. You know, corn is subsidized. We ship it in. It will fatten them up very, very quickly. But cows don't have the stomach to handle the corn, and they get very, very sick. They're supposed to eat grasses, and they get a lot of diarrhea and stomach upset. So if you do this, well, golly, you're going to have sick animals. So, better get yourself some antibiotics in there. And there you go. So, routine administration of antibiotics to food animals, very common. And here's some turkeys if you're wondering about them. And what they will do throughout the whole life of the animal is give them low doses of antibiotics. Yeah, not high enough to really kill the bacteria, but certainly enough to kill off the weaker strains of bacteria. But the ones that are somewhat resistant to antibiotics, okay, they're going to live, and you're going to have a whole sea of antibiotic-resistant bacteria. So what can go wrong? Oh, back to this, by the way. These antibiotics, we do know that giving cattle and pigs, and probably birds too, antibiotics will make them fatter. Okay, it will increase productivity. And I don't want you for a moment to think that I am pointing fingers at modern farmers. You know, people who raise cattle, they barely eke out a living. And a lot of people who run some of these operations, it's very hard for them to keep things going. One little misstep and they could be wiped out. So I'm not saying that, that they are not doing the best they can in many, many cases. But I think we need to revisit how we do this. But anyway, as adding antibiotics makes these animals fatter, just a little side note here, not only will that help to make more and more resistant bacteria, keeping things at a low dose, but we know that it makes animals fatter when they consume low doses of antibiotics throughout their whole life. So if you eat animals that have been fed antibiotics, are you going to get any antibiotics there? Maybe low doses throughout a lifetime? Just saying. And the worst part about this, of course, though, nobody wants obesity in this country, but the antibiotics they're pouring into the feeds, these are the same antibiotics used to treat people who have illness. Okay. And as well as when an animal really does get sick, okay, they need those antibiotics too, and so do your pets. So what's going to work on them when they really need it? So there's a lot of foodborne illness these mostly bacteria, some viruses that contaminate, they contaminate the whole lot. It gets into the meat, and then at slaughter, there's lots of bacteria in the carcass, and the bacteria could very easily be resistant. And understand too that once you get sort of this big pool of antibiotic resistant feces, not only in water, in the soil, in the food, well, okay, again, this is going to probably produce some very interesting genes and bacteria, and this is going to cause a huge opportunity for new resistant strains of bacteria. And this is another reason why there are just some people who cannot be treated with antibiotics. Also, a lot of animals like your pigs and your cows are given steroid hormones at very, very low doses. Normally it's inserted around the ear. So steroid hormones, there's arguments on both sides of that issue. I'm not crazy about it, but I don't have a strong opinion one way or the other. But it does increase growth rate, and it helps the farmers, it helps their bottom line, which sometimes they really do need. And it helps them produce a better product, meat with less fat and more lean mass. So there you go. This is just to show you too, though. Here's one of the risks of having a CAFO, and if someone tries to grow leafy green vegetables close to it, well, okay, you've got all this runoff. So all this runoff, and is that water going to stay put? Probably not. And what if you have rains, heavy rains? Well, this could easily get into somebody's garden. So here's the feedlot pens over here. You get heavy rains, and whoops, guess what? It gets into the garden. So um, you get in these feedlots, you get some of the nastiest kinds of bacteria. They do come out of these feedlots. E. coli is biggest of all. And the E. coli that we get probably have genes for some very nasty toxins that we wouldn't normally see. So this is a way for E. coli to get into your crops. Okay. One final note before I forget. We have a lot of evidence that suggests that if you keep cows on a grass-fed diet, or at least for the majority of their life, maybe at the very end, give them a little bit of corn, that will really reduce the amount of very toxic E. coli strains that they will carry. And I will hopefully talk about this in part 2. Okay. And here we go again. Here you have pig confinement areas, and here's a pig manure lagoon. And if you have any farmland around here, well, and you should know E. coli really knows how to hold on to leafy green vegetables. They have things called pili, and once they hold on, they are hard to get off. This is something from Consumer Reports, by the way. I just wanted to mention again that cows are supposed to be grass-fed. They really are. Everything we put them through in order to get a McDonald's hamburger is very unnatural to them. So I'm sorry I had to blow this up, and I know that it's not the pixelation's not the hottest, but this is just to show you from Consumer Reports the difference between the two populations of cows. So here we have conventional cows raised in a confined area, and here we have the grass-fed. And we know for the first year or so, cattle are raised on the pastures, even the ones that are going to be in the confined areas. But then they're moved to the crowded feedlots where each cow is confined to as little as 23 square feet. The space they occupy has no vegetation and can become muddy and covered in manure, as I mentioned. The grass-fed cows, they're grass-fed. No, in the feedlot again, corn and soil are the primary foods, but the cows may also be fed candy. By that, I do mean chocolate, like M&Ms and potato chips. Okay, so whatever Nestle next door has as a waste product, they will feed it to the cows. Sometimes they're fed chicken coop waste and slaughterhouse remains of pigs and chickens. And sometimes they're even given plastic pellets as substitutes for fiber. Um, Cows eat grass, they forage legumes, cabbage, kale, mustard plants, so forth and so on. And again, well, you can read that at your leisure. So when it comes to the ones in conventional confined areas, of course, they're going to be very prone to infectious diseases, and plus to encourage more growth and mass and fat, they're given antibiotic hormones and other drugs. So, and grass-fed cows might be given antibiotics, this is true, but generally it's not needed as often. And most of the grass-fed cows now are being sold to the organic market because they can make a lot more. So they try not to give antibiotics so they can say organic, and there you go. So when it comes to slaughter, large meat processing plants slaughter as many 400 head of cattle in an hour, and some of the practices are pretty inhumane. And you only have to watch some of the videos. I can't handle them myself, but feel free to Google and look on YouTube. Usually grass-fed farms take their animals to smaller regional plants, or maybe even to the local butcher if there is one, and we have a few in the Omaha area, by the way. Um, so when it comes to antibiotics in agriculture, you should know this is from the Pew Charitable Trust. So within the grain that the animals are fed, huge amounts of antibiotics. It's estimated that when it comes to those low dose antibiotics given unnecessarily to animals. They get about 29.9 million pounds of antibiotics every year when it comes to the US. And for humans, we get about 7.7 million pounds. So, yeah, by far the majority of the antibiotic abuse is in the way we raise our animals for meat as well as for poultry. And by the way, of all the ways of all the methods, poultry usually uses the most antibiotics. They have tons of antibiotics in poultry feed. So, what are some of the consequences of antibiotics just loose in the environment, used in agriculture without really using good stewardship? Well, let's talk about this. There's a group of antibiotics commonly used called tetracyclines. Now, if you're not familiar with the word, if you know what doxycycline is or minocycline, people with acne are commonly given minocycline. Skin problems are given minocycline. So know that this antibiotic is very broad spectrum. So it kills the good guys as well as the bad guys when you take them. Sometimes we need this for diseases like Rocky Mountain spotted fever, as well as for acne treatment. And people with acne would probably tell you that's important to them. Okay. But the problems with tetracyclines and just abusing them is that it is an endocrine disruptor. Yeah. And we do know that if you're on tetracyclines and birth control pills, you may not be protected by the birth control pills. We know that it is an immunosuppressant. It depresses your immune responses. Okay, that's not sounding like something I just want to take just because. We know that it can deplete your iron, your available iron. Okay, that's not too good. We know that it concentrates in bones and teeth. People who are given antibiotics of tetracycline when they are young, they get discolored gray teeth, which, by the way, also fluoresces in the dark. And there's nothing you can do about this except for get your teeth capped. It is a really huge problem in a developing fetus, okay, because it can deposit in the bones and it can cause birth defects. So this is bad. We don't give this to pregnant women, nor do we give this to young children. Now, there's also a problem of photosensitivity. Now, did you ever get a rash and you wondered, I wonder where this rash came from? Well, here's a little story. Friend of mine, microbiologist, he was a runner. He was postdoctoral student from Creighton, and he had a really bad rash. And he was asking one of the fellows, the infectious disease MD fellows, and he says, "Yeah, gosh, I got this rash. It looks really weird. What do you think?" And the doctor said, "Well," it's like, "Yeah, were you taking antibiotics?" And my friend was kind of insulted because his thing was antibiotic research. So of course he would know he was taking an antibiotic and know that that causes photosensitivity. So he gave sort of a nose in the air, please, I would know better than that. And the doctor looked at him and said, okay, so are you by chance eating Kentucky Fried Chicken? To which my friend blinked at him and stared at him and didn't quite know what to make of that particular question. But here's the thing. He did as a grad student. He wasn't eating very well. And by the way, Kentucky Fried Chicken is not the only one that 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 gives you a little something extra in the bucket. But here's the thing. The chickens are raised with so many antibiotics and tetracyclines that a lot of it's still in the tissue. So by eating Kentucky Fried Chicken, he actually had a lot of low-dose tetracyclines in his body, enough to give him photosensitivity. So voila. And oh yeah, remember all the problems that this drug can cause. How about something else, just using antibiotics in agriculture? How about some natural honey? Well, okay, let's look at a drug called chloramphenicol, and this drug is nasty. It attacks the mitochondrial ribosome. If you remember, in cells, the mitochondria is the powerhouse of the cell, and they have their own ribosomes that make proteins. So anything that can do this is not good. Now, it doesn't hurt everybody, but it can. It has this particular risk, okay? It's very broad spectrum, and we tend not to give it if we can help it in this country. So it's highly regulated. If this is used, if it can be used. Some people have bad results with it. Some people do not. We call this idiopathic. And in fact, that again, you can't determine who's going to get a bad effect. One particular case that I will tell you about was the case of, well, there was a young girl who was given chloramphenicol for her prescription, and she stopped taking it because she was feeling better, thinking that all the bacteria were dead when her symptoms went away. Well, and my mom used to do this too. So what was left of the antibiotics went into the medicine cabinet, and her father, feeling a cold coming on, colds caused by viruses, took one chloramphenicol. He died. So what happens is it can cause, because of its possible effects on mitochondrial ribosomes, it can cause aplastic anemia, and sometimes to a very lethal extent. Sometimes 1 in 20,000 is what they estimate will have a severe complication of aplastic anemia in the bone marrow. Some of the other things that it could cause is vomiting, green stools, and gray skin. Move to, what about the honey? Okay, we talked about honey. Well, China was experiencing some problems with their bees some years back. And some countries do not use regulation very well, and very consistently or at all. And China, okay, so they were worried about their bees, and they did discover the bees had a bacterial infection. Bet you didn't know bees can have bacterial infections. They can. So they thought, well, what should we use? Yeah, you guessed it. So chloramphenicol being broad spectrum, they sprayed the hives. The bees were healthier. They didn't die with the bacterial infection so much. But the honey was shipped all over the place, and people were getting idiopathic problems. So look at the problems. So again, you have to be really careful about using antibiotics in agriculture. You have to be good stewards. What you use, when you use it, how you use it. Without regulation, terrible things can happen. So again, just a thought. So what happens to these antibiotics used in agriculture? And maybe the bacteria that didn't all quite die, and maybe some of them became antibiotic resistant. Maybe they ended up in the feces. Where did they end? Where did they go? Okay, well, okay, they're not in the feedlot because they'll be sprayed out, or, maybe some of the workers will carry them home to their families. But okay, so you have a manure lagoon there. Surely it can't get into anybody's groundwater or anything, or leach into anybody's crops. But the cattle are going to be covered in feces and these bacteria and antibiotic resistant bacteria. So anybody handling these animals are going to be exposed and could be colonized by antibiotic-resistant bacteria. The meat that you get could have bacteria, and they could be antibiotic resistant. Now, the good news is it's okay if you handle these well, you wash your hands, okay? You clean your utensils, you don't cross-contaminate, you don't use the same knife or the same spoon to spoon up your hamburger patties and use it to spoon up, I don't know, watermelon or something like that. So keep everything clean and cook your hamburgers through and through. Okay, but this is a risk, and if you don't cook your hamburgers, big problem. So, okay, why should we worry about E. coli? Well, again, some E. coli can carry genes. We talked about this in a previous lecture. Sometimes you can get enterohemorrhagic E. coli, and they do live in cattle. And again, most cattle that are, well, the most enterohemorrhagic E. coli that we see are going to be in cattle that are raised in CAFOs, much more so than on the farm with the grass-fed beef, okay? So there's several ways that we can improve some of this, right? We have to be very careful about cross-contamination of carcasses and foods. The problem is a lot of times when your beef hits the processing plant, you have beef from factories all over the place, maybe even Canada. So trying to figure out where the original E. coli cow came from might be almost impossible. Increase in-plant effectiveness. Maybe be very careful about the water and the water that leaves. Be careful with irrigation and runoff. Again, we don't want to have water running into spinach. There's always some spinach contamination or fruit. Somebody's watering their fruit or watering their plants with water contaminated with runoff from a facility. Also, be careful in agricultural fairs and open farms, petting zoos. E. coli can last a very long time in just the dust, so be careful there. And and also we have to be really careful about farm worker safety. And again, if there's E. coli out there, there's going to be dust all over the place. By the way, there was one particular case study that I heard about. There was a farmer who used to raise his hogs in a confinement, and one of the hogs actually attacked him, and he got a small wound and kind of kept going. But from the hog, he got a bacterial infection from Campylobacter, and he almost lost his leg because of it. So, and because the reason for it was because the Campylobacter that the pig gave him was antibiotic resistant. So here you have the farmer who grew antibiotic resistant bacteria in his hogs because of the way he was raising the hogs, and he could have died from it. He was given a bite and an infection that he couldn't treat. By the way, he did switch to organic after that. So, when it comes to antibiotics, the CDC estimates at least 2 million Americans contract antibiotic resistant infections every year. This is in America alone. About 23,000 in the United States die as a result. And again, and this isn't just, anybody. Again, people who work on the farms, they're at a big risk there. Okay. So I did want to tell you, though, the most powerful influences that we have in agriculture. Well, I could have put Walmart in there too. Walmart is a huge, huge influence on how food is produced, but also McDonald's and Burger King, very big. There are a lot of protest rallies that said that, okay, we don't want antibiotics anymore in our meat and our eggs and our chickens, that sort of thing. And they were also saying they wanted, animals to be cared for better, have more room, fresh air, things like that. And they pretty much had to listen to that. And so now there's a bit of a chain reaction. This is from Consumer Reports. And there are some companies, if you like fast food or faster food, probably those companies that are more responsible, especially when it comes to antibiotic produced meat and dairy products. Number one is Panera and Chipotle. Chipotle is very good. They really are. Subway's pretty good too, if you've heard about that, and I guess Chick-fil-A. McDonald's is kind of getting there, sort of Wendy's and Taco Bell. Hurry up, Taco Bell. Pizza Hut, not so much. Papa John's, doggone it, Papa John's. They got a D. And we have all of these down here, including Starbucks. Well, I'm a Scooters person anyway, so there. Burger King is improving, at least they say they are, but yeah, not good. The trend is, right now it's pretty good to, a lot of these corporations are saying that we're going to raise our birds more humanely and antibiotic free, and hopefully they're going to be increasing beef and pork raised without antibiotics. But some of them, like Subway, is saying, well, maybe not until 2025. But still, I guess it's progress. Uh, just so you know, most European countries don't do this anymore. They don't do the antibiotics. Okay, so some of the other problems with CAFOs, the environmental impact, well, cattle, um, they belch and they toot methane, and it does contribute to global climate change. More on that in a little bit. And again, cattle and swine waste are stored in lagoons, sometimes sprayed on fields, released into the water, and again, you get nitrogen loading and you get eutrophication, and we're back to this again. So not good. And you know, again, the more manure you add to these water systems, the less oxygen you're going to have, and it messes with the whole ecosystem. So we'd rather not. Slaughter and meat processes, sorry, really quick. Sorry that I should have turned off my cell phone. Just to talk about some of the slaughtering and meat processing practices. Animals are stunned, bled, cut into parts. These cause hazards to workers. Of course, it can cause injuries. If you're operating something like this, you can imagine where this could be very dangerous. You can get cuts, slips, falls, repetitive strain injuries, zoonotic illnesses, respiratory irritations, noise, heat and cold exposures, and some evidence of cancer risk probably because of the stress. My brother once worked in a slaughterhouse, and he said he could only handle it for a day. He says he just couldn't do it. This is his early years. He went on to be a conductor for the Burlington Railroad, but he said, yeah, he just couldn't handle it. It's pretty bad. And as we mentioned before, of course, the way meat is slaughtered and processed here is a source of foodborne illness. Fecal matter can contaminate animal flesh on a fast-moving production line. You just never know. Hopefully, everybody is protected with personal protective equipment, but sometimes, sometimes people forget or they knowingly forget. Again, there, especially with poultry, most poultry that we know of in these particular facilities has some Salmonella, Campylobacter that can cause foodborne illness. A lot of the beef well, just everybody has E. coli, but a lot of the beef, especially the beef raised with in the feedlots, there's a lot of toxic beef. Or a lot of toxic E. coli 0157H7. I just wanted to show you this is something from Reuters and a 2014 report that talks about Salmonella superbugs on the rise, and it goes from 2002 to 2011. So just looking at the percentage of packages of retail store chicken tested by FDA were found to have Salmonella. So this is quite here. I don't know what was going on in 2009, but over 20%. And if you go up this way, a percentage of those Salmonella, which were resistant to at least one antibiotic. So how scary is that? Rendering of animal carcasses. Oh, goody. So, little background about rendering, and some of these pictures are horrible. I had to keep going when they had all the dead cats. But there's a lot of stuff that gets dumped into these rendering facilities. So, animal carcasses, not just the food animals, but any animal gets, that after slaughter or euthanasia, become, waste handling problems. So what they do as a a recycling technique converts carcasses into useful products, such as meat and bone meal fed to cattle. So cattle eating cattle, and also so here's some pellets here. And tallow. Now, tallow goes into a lot of different things. Sorry, let me move back here. So sometimes if you have natural candles, they're made up of tallow that came from a facility like this. And they go into a lot of food, a lot of oils and beef oils and beef broths and things like that. Um, And we could talk, I'm going to just really go into the prions again. It was this practice that was the source of prion diseases. Remember spongiform encephalopathies and the breakout in Great Britain of prion diseases in cows, okay? So, and the other thing about rendering is the smell. Pooey, pooey, pooey. So I'm not going to go into the prion diseases. You already know about that. And of course, this horrible picture of the poor downer cow. But when you feed back animal products to these animals, especially animals that aren't supposed to be carnivorous, and they're certainly not supposed to be cannibals. Okay, sometimes things happen. This is, when you go against, sometimes when you go against nature, nature comes back and bites in a big way. Of course, spongiform encephalopathy can occur in humans, and we call this Creutzfeldt-Jakob disease, and this is the deaths from CJ disease or Creutzfeldt-Jakob disease in the United Kingdom, with the biggest, the greatest number of deaths in the year 2000. And it's starting to decline with a little bit of an increase again in 2001, so it's a bit of an increase. Makes you wonder. When it comes to dairy farming, a lot of the dairy farms are consolidated into larger operations, and they are less likely to be family owned than they used to be. Like in my uncle's farm, he did have a few dairy cattle, but he would also grow his own feed, and so everything was taken care of there. Now it's massive, so it's gone from this to this. And a lot of times dairy cattle are given growth hormones that has been genetically engineered. I don't know if that's a big deal or not, but there it is. And it's given to the cattle for increased milk production. But again, you have an operation like this, it's going to cost you a lot of money. And a lot of people, how are you gonna keep your smaller operations going and to compete with the bigger operations? So it's pretty difficult. Impact of modern agriculture on global climate. Well, okay, so the way that we have, that we produce plants and animals these days, again, a lot of fertilizers, more than enough cows than really we probably should have, and other feed and other animals for food sources. Well, they're going to produce nitrous oxide, and you get this from a lot of bacteria. The bacteria are going to convert nitrates from the fertilizers, from the feces into nitrous oxide. Not, again, this is one of those products that is one of the greenhouse gases. Methane is a product from belching and tooting, okay, flatulent cows, right? What happens is the cows are eating their food and they have something, they have in their guts bacteria that convert that food and break it down and ferment it. And what comes out both ends is gas, and it's not just any gas, it's methane. So, and a lot of methane also can be produced by the bacteria that are found in lagoons and also crop residues in rice paddies. So I just wanted to show you that methane and nitrous oxide are both extremely potent greenhouse gases, more than CO2 released from your cars and from factories. And I have this is from New Zealand flatulence tax, outrageous farmers. So the BBC ran this in 2003. So they were trying to control sometimes government policy sets taxes in place to maybe control certain problems. For example, cigarette taxes, that sort of thing. Well, New Zealand, the government in New Zealand, they were trying to give a flatulence tax. But what the reason I have this here, it's not only funny, is it shows that each cow was eating 50 kilograms of grass per day. And from that, you would get 250 liters of methane coming out, as well as 1,500 liters of CO2. But again, methane is the nastier of all the greenhouse gases. something we really don't. So, do we really need to have as many hamburgers and steaks every day, every week that we have? Well, and oh, just this just shows you again, this is just breaking down that livestock produces about 4.2% of greenhouse gases. This is from the EPA, an EPA figure. So with cattle producing 2.2 of that, and pigs behind that, chicken behind that, and horses aren't in there, of course. So I just wanted to show that. Um, a lot of conscientious people suggest something called a meatless Monday. And something to consider, if all U.S. Americans practiced a meatless Monday, turns out it is estimated that we would reduce the U.S. national greenhouse gas emissions by 0.6%. And if we did this every week for a year, we would cut our total emissions by 0.3%. So this is so if we just don't quite have the big cow demand or pig demand, maybe go with an alternative, and maybe be a little more heart healthy, just one day a week. But I'm just laughing, and I thought, okay, so this would have to be followed by Taco Tuesday, but I'd have to find a good, responsible taco place. And again, Taco John's is not as responsible as we would like. Okay, that's finally the end of Chapter 6, Part 1. I told you that we wouldn't get to that other objective yet, but we will continue that next week. You all have a very good week. Let me know if you have any questions.